Welcome to Geometry Pre-AP. Today we're going to be learning about the area of triangles, parallelograms, rectangles, squares, and combination of that figures. We're also going to learn what Heron's formula is today and how it can be used to find the area of a triangle. All right, so we're going to set things up here. All right. As we start our video today, here are the basic formulas. If you have your postulates and theorem sheet out, you can highlight these postulates and theorems. We have the area of a rectangle, which is area is equal to base times height. The area of a square, which is area is equal to s squared. Area of a parallelogram, where the area is equal to the base times the height. And we're going to talk about that on the next page because those two terms need to be looked at very carefully. And also we have the triangle, which is area is equal to 1/2 base times height. And again, there's that word, that base and height, which is going to be very important throughout the semester of looking at the figures to see what's what. So here is, again, those two formulas. So if I look at this first parallelogram, we're going to call it parallelogram A, and this is parallelogram B. In parallelogram A, this piece right here is your base, or this piece could be your base. Either one of those could be your base, and your height will be here, which we must have a right angle, or the height could be out here on the outside. So it doesn't necessarily have to be inside the triangle. Now here is the same parallelogram as above, but I have turned that parallelogram. So now this piece can be considered the base, and the height can be here. Or again, the height can be on the outside. And this is also a base. Remember that in a parallelogram, the bases, the sides of opposite sides of a parallelogram are congruent. So this is the same figure as the one above it. So be careful which side you look at. Any side on any figure could be considered a base. So here we have a triangle. We have triangle A, triangle B, and triangle C. So I've redone the triangle here for all three. And so when I have these triangles, I can have this is my base and this is my height here. Must be a right angle. This is the same triangle here. I could call this my base, and my height would have to be at a right angle. So this would be my height. And I can even have another one here where I have this is my height, and this is my base. So actually any side of a triangle at any time could be the base, and the height must be perpendicular to it and go from a vertex to the side across from it and make a right angle. And that is what will trick many people up when we start twisting our figure around and making them go different directions. So our first formula for today is actually our Heron's formula. So this is our Heron's formula. We need to learn this one where we have sides A, B, and C. And so in the formula, the perimeter of this figure is A plus B plus C, but the semi-perimeter is equal to the perimeter divided by 2. That's what the S stands for in the problem. And so when we put those numbers into the formula, we work it out, we end up with the area of any triangle. Notice we don't have a height, a base, or anything. We just have a three-sided triangle with no height in it, and that's where this formula applies. So we're going to do a couple practice problems. All right, so again, there's your formula. Remember that the S is on the outside, S minus A, S minus B, and S minus C. So here's our first example problem. Okay, as we practice this one, first you want to start with finding the perimeter, which would be 6 plus 10 plus 14. That is going to be 20, that's going to be 30 total. And so the semi-perimeter will be 30 divided by 2, which is 15. So we go to our radical. We got the semi-perimeter S times 15 minus 6 times 15 minus 10 times 15 minus 14. And so when we're working Heron's formula, what happens is a lot of people want to just multiply all these numbers together once they have them, but that's not necessarily the smartest way to work. So we want to work smarter, not harder. So this is going to be a 9, this is going to be a 5, and this is going to be a 1. So we want to look for perfect squares in here. So we have a 5 times 3 for 15, which we can bring those two 5s together. So that's a 25. So if I circle here in green, this 5 and this 5 come together to make that 25. I've got this 9 that I'm going to bring down. And then I've got this other here, 3 in black here, that was a factor, and it comes down. And so the square root of 25 is 5, square root of 9 is 3, and I have the radical 3 left behind. So my answer is 15. Square root of 3 is my area for this figure. All right, and that's how you find the area of any triangle where you're not giving a height and you're only given the side lengths of this figure. And it can work for isosceles, it can work for scaling, it could actually work for any triangle. One of the keys that you look for is there's no height or way of putting height in the problem. All right. So if we go to this next page here, all right, this is going to be one. It's got a star by it, so you're going to do this on a separate sheet of paper, and you're going to turn this in with your notes that you have. So pause the video at this time, do this problem, and then start the video back up again to work for the next section. All right, so you should have an answer to this problem. Let me remind you that not all answers have radicals, and your answer for this problem was not a radical. It was actually an integer answer. So let me remind you that you're looking for those triangles where you just have numbers. Okay? Heron's formula is best if you, again, don't multiply all the numbers out and get a large number, because then it's harder to simplify. Instead, leave them as their factors and find the perfect squares that are inside those radicals. All right, so here are a couple triangles. These are equilateral triangles. Now, you could work these with Heron's formula, but another formula on your formula chart that you had was the formula for an equilateral triangle, which is s squared, square root of 3 over 4. The s stands for a side length. So if I go here to this equilateral triangle with sides of 8, area is equal to 8 squared, square root of 3, all over 4. Area is equal to 64 square root of 3 divided by 4. And our area is equal to 16 square root of 3. So there's our area. Don't forget your units in here. This is units squared. All these problems are areas. Expect to see those units squared. All right, so you can pause the video and do this green one that has a star by it. This will be put into your notes that you'll turn in when you come into class. So pause the video now, do this problem, start the video back up when you have it done. All right, so here we have a couple more practice problems. These are shapes that are composite shapes, so there's multiple different shapes in here. You have to break it into the shapes that you know that you can find the area of, and then find the sum of all those areas to get your final answer. So in this problem here, there are a lot of different ways. We haven't learned trapezoid yet, so we're actually going to just break this into a triangle, and a rectangle. We're going to assume that these are all right angles. So this is a right angle, these are right angles here and here and here. Now we don't know this value, so we need to find that value right there. So we have this 30 down here, which means we have a 30 here. We have a 16 here, which means there's a 16 here, which leaves there is 24 left from there. Yep, there we go. All right, so now we got the 24 there. Now that we've got all this done, we can go back in and we can find the area of each piece. So we have part A, part B, and part C here. So area is equal to A, which is a triangle, 1/2 30 times 16, plus area B, which is just a rectangle, which is 16 times 30, plus area C, which is 1/2 of 30 times 24. Because this is also a right angle right there. And so when we get all those numbers added together, we do that work, we end up with 240 plus 360. Well, actually, no, that one's not 360. That one right there is 480 plus this last one, which is 360. So when I combine all that together, I get 1,080 units squared. And that's the area of this composite figure. Remember just to draw in those lines in there so that you can get this broken into smaller shapes that you can find the area of. All right. So this next one over here on the side, you're to find that. Just a few hints for you. This is like a rectangle. Part A is a rectangle. You got some right triangles here that you can find the areas of, and that will help you find the area of that one. So put that one in your notes, pause the video, do that problem, start the video back up again. All right, so you should have that problem done. Let's go to this next problem. A little more complex shape here. You kind of have to really start looking at these shapes and breaking them apart into smaller pieces. So here's what I see when I see this problem. I could put in a line right here to connect those two. And when I did that, that would make more right angles here. And so actually what I end up with is a square in here. So I've got part A, part B, and part C here. Now, since part A is equal outer triangle, part B is equal outer triangle, and C is a square, I can do my formula for the equal outer triangle. So these are all 12s everywhere. So you got these 12s there. So that means S squared square root of 3 over 4. I've got two of those. Those two triangles are the same, plus my square, which is going to be S squared. So 2, my parentheses, my side is 12 squared, square root of 3, all over 4. Close that, bring in my 12 squared. Well, I can cancel this with this to make a 2. That's 144 divided by 2, so I get 72 square root of 3 plus 144. Now, I don't like writing my answers that way. The units kind of get messed up. This 144 looks like it's added to the square root of 3. So I rewrite this 144 plus 72 square root of 3 units squared. So remember to take these shapes that are composite shapes like this and break them into smaller pieces. All right, this one's for you to do. Okay, so take your time to do this one. Pause the video, work through this one, and when you're done with this one, you'll be done with your notes, and then we'll see you in class the next day so that you can ask questions if you had any problems, or just start on the work in class. Pause the video. Start the video back up again when you're ready to check your answer. I'm only going to put the answer for this one. I'm going to want you to turn in all your work. All right, if you start the video again, your answer should be the area is equal to 27 square root of 3. Give you a hint here. You need to find that value right there so that you can break this into two triangles. All right, and so your lesson's done. See you in class tomorrow.